And now it's time for Long's Logic.
So, how you doing, Robbie's class? So, two forces against the rope. There's tension. I'm pulling just as hard as the boat is pulling against me. It's simple physics, honestly, I mean.
As correct as you are, Chris, there is a lot more to this than just simple physics. When you speak of tension, you're actually talking about the rope undergoing a stretching force. When you were talking about the rope and the boat pulling equally hard on each other, you were actually talking about Newton's third law, which states that every action has an equal and opposite reaction. This brings a question to mind. If the boat and wakeboarder are pulling equally hard on each other, like Newton's third law states, then how is there any movement at all? If we look at wakeboarding as a system, we can see that the action force is the boat and the wakeboard, and the reaction force is the tension within the rope.
These vectors are insane right now.
Yes, Chris, the vectors are insane right then, but only if we could see them. With all of this information, we still have not figured out how the wakeboard is actually moving. Something that can help you understand more is if you think about a tug of war. In a tug of war, the only thing that is keeping someone from slipping is friction. The minimal amount of friction in the water means that our direction is inconclusive. The only reason that a wakeboarder has movement is due to the propellers located at the rear of the boat. Thanks to the constant movement of the propellers, the wakeboard is able to follow the boat and wherever it is steered and directed constantly. So with that in mind, remember that all of the reaction forces are equal, but the net force is moving in favor of the boat.
About the cohesiveness of water, the covalent bonds, you know what I'm saying? And with my board right now, the surface tension is keeping me going on the water.
Not exactly, Chris, but you're onto something. In water, the liquid molecules are pulled equally in every direction by neighboring liquid molecules, resulting in a net force of zero. The cohesive forces among these liquid molecules are responsible for what's known as surface tension.
The break in surface tension forms the wake.
As the board moves, it's colliding with water molecules formed by surface tension. The water molecules push up on the board with the same amount of force that the board pushes down on the water molecules.
And that concludes Long's Logic.
Yeah!
Thank you!
Thanks, Robbie.
Thanks.
Love you, Robbie. Boys. What up, Robbie? Sir, there you go, Robbie.
Hey, Mr. Robbie.
Say hello to Robbie. Say hello to Robbie for me.
Hello, Robbie. Hey there.
What's going on, Robbie?
Daddy.
This is for you, Robbie. I'm doing this for you, Robbie. I will not let Jacob use the GoPro.
Forms the wake.
Okay. I can do
Colliding with water in water, it's colliding with water direction by neighboring.
I don't know what I'm saying right now.
I can feel the physics.
Oh, 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 no, no. Oh, 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 no.